Scott Anderson is one of our fabulous tech writers here at InfluxData. And I have to say, Scott knows Flux inside and out. And when you read his documentation, thank God for him, because he makes it super clear. And he also has done a couple of videos for us. One's on the YouTube channel and one is on our website. Just a really fantastic introduction that he provides using a pond and a water tank. And I think that example just makes the filtering of Flux queries just so much understandable. It's kind of funny that it's like a real live filtering happening, and then there's filtering in the query. And if you take a look at the video, you'll understand a little bit more about what I'm talking about, but it sure made the light go off for me. So Scott, if you're ready, I'll let you take it away and talk about InfluxDB tasks.
I am ready. Is everyone seeing what I'm seeing, my screen?
Yep.
Perfect, perfect. So I guess I'll start off with a quick introduction, and thank you, Chris, for the kind words you had to say about me. Again, my name is Scott Anderson. I'm a senior technical writer and the technical lead of the docs team here at InfluxData. I have a fairly untraditional background career-wise in how I landed in a role as a technical writer. My formal education is actually in graphic design and marketing, but I was raised by a college writing professor who instilled some pretty strict writing habits in me, and just my career path and certain companies that I worked for, I just kind of ended up in the tech world and doing technical documentation. But I found something interesting. Part of the reason I went into graphic design and marketing is I loved creating things. And what I found throughout my career is that my passion truly is creating, and the medium doesn't necessarily matter. And that's one of the reasons that I've really come to love InfluxData and InfluxDB. Is just a crazy amount of stuff that you can build with it, the flexibility that it provides and the potential that it provides in just building really cool things. So today I want to talk about InfluxDB tasks. Some of you might ask, if you're not familiar with InfluxDB 2.0, what is an InfluxDB task? Simply put, a task is a scheduled Flux script. But underneath the hood, there's actually a pretty complex and powerful task engine that includes things like a scheduler. You can schedule your scripts to run on either set intervals or on a cron schedule. There's a task executor, there's a logger, there's a task queue, just a really robust engine to make sure that your tasks not only run on time and as expected, but also lets you introspect any task failures. So again, simply put, they're scheduled Flux scripts, but under the hood, there's a lot of power and a lot of introspection and visibility that you get into the execution of those Flux scripts. So why task? Where did they originate? Obviously, when you're working with time series data, there is this inherent need for automated repeated operations. That is the core role that InfluxDB tasks play, is just running these processes and these operations on a set schedule. But as we first started to build out the task engine, and especially as we integrated Flux with tasks, we needed a replacement for continuous queries from InfluxDB 1.x in both InfluxDB Cloud and InfluxDB 2.0. InfluxDB Cloud and 2.0 do not support continuous queries, primarily because they're dependent on InfluxQL. InfluxQL support right now, as mentioned before, is an API only, a client only integration. But it's tasks will fulfill that role. There is a bit of a migration process for taking a 1.x continuous query and converting it into a 2.0 task. But there's some tools out there that can help. Specifically top of mind is the Influx CLI has a transpile command that will take an InfluxQL query and transpile it into Flux. It's still in active development. It's still somewhat limited on the results that it produces, but it's definitely something that can help. But I think the majority of continuous queries that exist in the world out there now can be replicated fairly simply. But when continuous queries were first introduced, they were designed for a very specific workload, and it's what I call the downsampling cascade. You have all of this high precision data coming in. You have points every nanosecond, millisecond, second, whatever precision that you're writing data at. But on disk, it takes up a lot of space. So with the introduction of continuous queries and of retention policies, the continuous query will take that high precision data before it expires and gets dropped from the database, aggregate it down into a lower precision point, and then let the higher precision data expire while that lower precision data persists and may ultimately be downsampled again before that expires. This is all meant to preserve disk space and to just optimize how your data is stored long term. So this is an example of a continuous query using InfluxQL. We are taking the average of example field, we're writing that into the average example measurement, and each average is taken, we're taking 1 hour averages, and that's what's being written into the new measurement. This would be that same query, but in a Flux task, where we're querying data from a bucket. We are querying from either the last successful execution of the task, which the task engine API exposes that information, or all the data from the last time the task should have run, which is the task.every variable you see in there. We're querying the example in measurement and the field value, and then we're using the aggregate window function to aggregate every 1 hour window of data into an average, and then write that to our downsampled daily bucket in our MyOrg organization. So again, there's some really powerful downsampling workflows that you can accomplish with InfluxDB tasks. In fact, there's a downsampling InfluxDB template available on GitHub. If you go to our community templates repo, click on the downsampling directory. This is a template that was built by InfluxData's one and only Russ Savage that provides downsampling tasks for many popular Telegraph plugins. Not only does it provide the downsampling task, but it also provides a bucket and metrics to monitor those tasks and alert on those tasks. So if you're looking for some great downsampling tasks and some observability into how those tasks are running, highly recommend checking out this template. They're really simple to install and to apply both in OSS 2.0 and in InfluxDB Cloud. But today is about beyond downsampling. Really, the downsampling workflow that tasks were built to replace, that was the medium or the minimum viable product for InfluxDB tasks. But what happened is with the tight integration with Flux, is now with where you were fairly limited with what you could do with 1.x continuous queries. With tasks, you have the full spectrum of functionality provided by Flux. So there really is just a ton of stuff that you can do. And I just want to highlight a few of those potential use cases today. So the first one I want to talk about is monitoring and alerting. And many of you, if you've tried out the beta and the alpha and beta builds of OSS, or you've been using InfluxDB Cloud, you're probably familiar with the user interface for creating a check and a notification. Essentially, this is the UI where you create a query that pulls in data that you want to check against. But what you may not know is InfluxDB is actually creating a task on the back end. This is essentially a GUI for creating, or a GUI for a check task. So if we look at what that actually looks like, this is similar to what the raw code would look like that gets generated by the check, the check workflow, the check GUI. We'll just go through and look at each piece of what this query looks like. This check variable, this houses a record, a Flux record, which is similar to a JavaScript object, but it's basically a collection of key value pairs. This specifically is only meant for the InfluxDB monitoring API, but it provides information about this specific check. But you can actually write custom checks and use all the existing tooling and middleware that the monitoring API provides. So if you do want to use that middleware, you can provide this type of information in your custom check tasks. That query that you build using the query builder in the check UI, it gets assigned to a task data variable. Again, you're just querying from a bucket with a specified range, filtering by measurement and field, and then generating an average of that data. You then, in the second pane of the check UI, you actually define logic about the check. There's two types of checks. There's a threshold check and there's a dead man check. The dead man just simply checks if data has been written since the last interval, and if it hasn't, it fires an alert or it sets a status to that particular point or lack of a point. But as you see in the lower right here, you're starting to build out these, this UI screenshot here is building out a threshold check, but you start to define these thresholds. So going back to this generated task, I have a variable for each of the thresholds, where if a value is less than or equal to 60, the level or status is set to OK, and we have logic to define crit, warn, and info. You can also define the message that gets output from a check that then gets appended to that record as it's written into the monitoring bucket, which we talk about next. So we have our task data back here, this variable, that then we're using these assigned variables, the logic assigned to these variables to then take that task data. It gets pipe forwarded into the V1 fields as columns function. And all this does is it pivots the field column. So every individual field now becomes a column on each row. And then the monitor check function, this is the monitor function, or the monitor package is a package designed to work with the InfluxDB 2.0 monitoring API. And what the check function does is it evaluates every single row in the input data and assigns a status based on the threshold logic or the dead man logic that you configure in your InfluxDB check. You then are able to set up a notification rule. And what the notification rules do is they query data out of the monitoring bucket. And when, in this particular case, when a record or a row has a crit status, it will fire an alert off to Slack. On the back end, this creates just another task where we are configuring a Slack endpoint. You provide your Slack API token in the UI. It populates that here. You then use, again, the monitor package and the from function in that package, which queries the monitoring bucket for all of the records that match the logic that you define in your notification rule. You then take that endpoint variable, which in this case is sending to Slack, so every point that is set to a crit level will trigger a message to Slack. So right now, there are many integrations built into, alert endpoint integrations built into Flux. Just top of the list, we have Slack, PagerDuty, Pushbullet, Discord, Opsgenie, Sensu, Microsoft Teams, Telegram. ServiceNow is not in there yet, but there is an open PR on the Flux repo for that. And then for all of the integrations that we don't have specifically built for, there is an HTTP post function that you can just post to any publicly available API. This is not a comprehensive list, by the way. The HTTP logo in here actually it covers a lot of different services that you could potentially send alerts to, and not all of these are available in the InfluxDB Cloud or InfluxDB OSS UI, but all of these are available with just raw Flux. So again, InfluxDB provides this really robust monitoring system, APIs to interact with it, but there's actually a way to create just really simple custom alerts using the task engine. So here I have a custom alert, and I know Anais has already gotten a big shout out in the presentations today, but I'm going to give her another one because Anais is awesome. She has a background in data science, and she's actually provided an anomaly detection package to Flux. And what this task does is it imports her anomaly detection package. It defines a to Slack variable, which uses the Slack endpoint to send messages to Slack. It then queries the example bucket, filters by the M measurement. I then use the MAD function inside of the anomaly detection package, which is a well-known and established anomaly detection algorithm. It's median absolute deviation. I think I got that right. And if I didn't, Anais will correct me in the chat. But basically what this function does is it checks for any anomalies in the input records. And if there is an anomaly, it will add a level tag to that with an anomaly value. So after I process my data with this function, I then filter, I only want records that have that anomaly tag. So something to note about these endpoint functions, and this is the same for all of the notification endpoint functions that are in the Slack standard library right now, is they're what we call a factory function. You feed data into them and they actually generate another function. So I'm sending all these rows to Slack, my custom to Slack function, and it fires a notification for every single row that it receives. And that's important to understand as you're building these custom notifications, is when you pass a row or a record to an endpoint function, it will trigger a notification. So you want to be sure that you're only passing records that you want to trigger a notification. So in this case, again, this is a factory function, meaning it's a function that generates another function. So if you're looking closely at the syntax, you might see the empty parentheses at the end of this and say, oh, there's a typo. But that is actually incredibly important because those empty parentheses actually execute the function generated by the toSlack or the endpoint function. So this is just an example of a really basic, simple, custom notification script or alerting script that it doesn't use any of the internal InfluxDB monitoring middleware or the APIs. This just uses straight Flux to trigger a notification to Slack or any of the other available notification endpoints. So another really interesting use case that you can do with tasks is actually data ingest. And I'm a huge fan of Telegraph. Barbara and her team have done some amazing things. And Telegraph is more of, I guess I'd call it a push model from data, where it's pushing data into InfluxDB. But what tasks allow you to do is actually to use a pull model to ingest data and pull data from other sources. So for example, you can take CSV data. In this case, it's annotated CSV, which is natively supported by Flux. In fact, Flux only supports annotated CSV, and the annotations that it will accept are fairly strict. But once you wrap your head around the structure and the syntax for the annotations and the CSV as a whole, it's really easy to get data in. But this is taking in CSV data, annotated CSV data, and writing it to my org and my bucket. There's also an experimental CSV package that allows you to pull annotated CSV data from a URL. And we use this a lot actually in our documentation for our sample data. So we have these sample data sets hosted on S3, and you can actually pull that data from S3 and write it into a bucket, either in InfluxDB Cloud or InfluxDB OSS, and then tinker around with that sample data in that bucket and use it however you want. This is a recent addition to Flux that I actually love. Annotated CSV can be fairly hard to work with, especially if you're new to it. What the Flux team did is they introduced an experimental array package, which allows you to pass an array of records. Again, a record is just a collection of key value pairs. And it turns that array of records into a stream of tables, which you can then write to InfluxDB. So in this case, I have a stream of tables that is actually one table. And I have a time column, a region column, and a value column. And it's taking this data and writing it to InfluxDB. And I actually just realized a mistake that I have, because you can't write data to InfluxDB without a measurement in the field. So this data wouldn't technically write, but if it had a measurement in a field column, it totally would. There's also an HTTP GET function that allows you to pull information or data from HTTP endpoints. So in this case, I'm actually using the health endpoint of InfluxDB OSS to pull information about my local InfluxDB instance and passing it my InfluxDB authorization token. I'm then using the response body variable to represent the response body of my HTTP GET request. And I have a seed row variable that actually acts as a placeholder or a destination for all the data that I'm able to pull and then write to pull from that HTTP endpoint and then write to InfluxDB. So I'm using the array from function, the input is the seed row. I then take that single row and I start to map values out of the response body. I first parse it with the JSON parse function, and then because it's parsed, I'm then able to map each of those values out of that JSON that gets returned into a Flux column, and then write that back to my bucket and my org. So these are all potential data sources of available in Flux today. You have Postgres, MySQL, MariaDB, Percona, SQL Server, Amazon Athena, Snowflake, Google BigQuery, Bigtable, and Prometheus. And again, this is not an exhaustive list, but these are some high points. Most of these you get access to using the Flux SQL package, and you're able to query data from these data sources. So for example, if I wanted to scrape data from a Prometheus endpoint, and in this case, I'm using the metrics endpoint provided by InfluxDB OSS, I can use the Prometheus scrape function to scrape data at regular intervals and write that data to InfluxDB. This is an example of using Postgres, and we've already seen this example once in some presentations today, actually more than once. But again, just simple queries from Postgres, and the syntax for many of the other SQL databases is incredibly similar, if not the same, for querying that data. So what these data sources and this ability to ingest data, some other functionality that this provides that opens up a world of possibilities is data enrichment and enhancing the data both at query time and as you're writing. And what allows you to do this is long sought after functionality. We still get requests for it in InfluxQL, but Flux offers it now, and it works well. The ability to join tables. So for example, let's say I have a fleet of sensors all measuring temperature, and each of those sensors has a sensor ID. I'm storing time series data in InfluxDB, but I also have Postgres running, and I'm using Postgres as somewhat of a asset management database where I'm storing information about each of those individual sensors. What Flux join allows you to do is to take those two tables and join them together. So as an example task, in this task, I'm using the telemetry variable to represent the data that I'm pulling from InfluxDB. So I'm pulling from my sensor data bucket and my sensor data measurement with my field temp. And then I'm using the assets variable to represent data pulled from my Postgres database and all of the sensors stored, all the sensor information stored in my Postgres database. I could then use join to join those two sets of data on their common column, which in this case is sensor ID. And then I can write that enriched join data back to InfluxDB. So the written data would look something like this. It's those two tables of information merged into a single table or joined into a single table. Now, there is a caveat to this. If you are introducing a high level of cardinality by joining those two tables together and enriching that data, it might not be the best thing to do to write that data to InfluxDB. You can absolutely join and enrich that data at query time without ever actually having to persist that data to disk and introducing that cardinality into the storage engine. You can absolutely do that at query time, but there are use cases where writing that enriched data back to InfluxDB would prove valuable. Another interesting use case with InfluxDB is data transfer. So InfluxDB can pull all this information out, all this data from external sources, but it can also push information to external sources. So most of those SQL data sources that we had talked about before, you can actually write back to them and persist all of that data to those data stores. But I also, in this list, I wanted to include the HTTP endpoint and as well as both InfluxDB and InfluxDB Cloud, because there's this really interesting workload and workflow that we're already seeing with deployments on InfluxDB Cloud. And it's been mentioned multiple times here today, but it's one I want to explore a little bit and explain a little bit. So this is an example task. Imagine this task running on an InfluxDB OSS instance. So what it's doing is it's querying telemetry. It's querying data from the telemetry bucket. It's aggregating the average of every 5-minute window, and it's then writing that data to a InfluxDB Cloud instance. That integration is really simple. There's been a lot of talk about the unified API between OSS and cloud. This is that API in practice, and it proves how simple it is to transport data back and forth between an InfluxDB Cloud instance and a locally running InfluxDB OSS instance. All you need is a cloud token, a URL, an org, and a bucket to write to. It's really, really simple. But what this allows you to do is, and again, we live in an increasingly instrumented world. As Evan pointed out earlier, I mean, I'm wearing a watch that is measuring all type of biometric data for me. We have fleets of trucks that are being outfitted with sensors. We have buoys in the middle of the ocean that are being outfitted with sensors. So we see these clusters of sensors out on the edge collecting very valuable data. And what we're seeing with the introduction of InfluxDB 2.0 and InfluxDB Cloud is we see InfluxDB OSS being deployed either on the edge or near the edge as a data store for this high resolution sensor data. So you have all of this data being written into an InfluxDB OSS instance, where InfluxDB can then process that data, downsample it, and actually send it to InfluxDB Cloud. And not only send it to, but I mean, this is a two-way flow. You can have InfluxDB Cloud process information and send it down to an InfluxDB OSS instance. But imagine, you have this cluster of sensors writing into this near edge InfluxDB OSS instance, how easy it would be to deploy an entire fleet of sensors and InfluxDB OSS instances. All of these near edge OSS instances are processing data, aggregating it, and optimizing it for transport over the public network to an InfluxDB Cloud instance. So you aren't destroying your network bandwidth, and you aren't facing these high network costs because you're doing a lot of the processing on or near the edge. And then vice versa, you can send data from cloud down to these OSS instances. In fact, with InfluxDB Cloud, depending on the dashboard that you use, if you wanted to query an InfluxDB OSS instance, as long as it's accessible on the public network, you could query that from a cloud instance. It wouldn't be a problem at all. So this workflow gives you some really great observability, both on a macro scale and on a micro scale. You have the high precision data in your on-edge or near-edge InfluxDB OS instances that are all reporting back to the centralized data store with downsampled data that you can then operate on and look at a macro view and observe your fleet as a whole. So some other potential use cases that we've explored, and I just, for the sake of leaving time for some Q&A, I didn't want to go too deep into, but data sanitization is one, and this would involve like string manipulation, or as brought up in Barbara's presentation, there's a way to filter out noise based on anomaly detection algorithms and things like that. But just cleaning up data on a regular interval, especially as data may be coming from disparate data sources, there might be inconsistencies. You can use tasks after that data is ingested to resolve any of those inconsistencies and then rewrite the sanitized data back to InfluxDB. There's also a question about machine learning. So InfluxDB and Flux specifically, it isn't optimized for machine learning yet. It is definitely a major area of interest, and it's something that we plan to grow into. But right now, what a machine learning integration with InfluxDB and Flux looks like is essentially you could use a task to generate a data frame and send that data frame off to a machine learning framework or a neural network and have it process that data frame. Generating data frames with Flux is fairly trivial. Something else that Flux already provides is the ability to forecast data. And you can actually write that forecasted data back to your InfluxDB instance and compare real-time data versus forecasted data. There's already a number of forecasting algorithms built into Flux that allow you to do that really easy. You can generate reports with tasks. I mean, even with APIs out there, I mean, you can send data to an API that will generate a report and send an email to an entire team of people, which goes on to the next point here of event triggers. Using a task to somehow hit an external API that then triggers this cascade of events that happens. Already possible, really easy to execute. Something that I've actually prototyped with just toying with sample data and trying to develop data sets that our community would find useful just as they're trying to tinker with and get to know InfluxDB. We prototyped a InfluxDB task that takes seed data, writes it to InfluxDB, and then queries that written data in set intervals, increments each of the values in the data, and then writes the incremented values back to InfluxDB. So you have this looping cycle of writing data, querying that data, incrementing the data, and then writing it back. So just some really interesting use cases around data generation, event triggers, reports, all of this stuff. There's just the world is your oyster when it comes to what you can do with InfluxDB tasks. I mean, really, the only thing you're limited by in InfluxDB tasks and what you can do is the capabilities of Flux. And Flux is still a young language. It's maturing constantly, and I'm super excited for what the future holds for Flux. I know the Flux team is working hard, and there's some really, really cool stuff coming down the pipe. So thank you. I did leave some time for some Q&A, so I will open it up. I see a few questions. I don't know if Chris, you wanted to jump in and drop any questions up front.
Oh, you can ask those questions first. I have a few myself.
Okay, so from Joel Simaru, or I probably just butchered your name, sorry. Is sideload function still maintained? Also, is there another way to suppress a task from firing, silencing the alert? Sideload, kind of. So I'm somewhat familiar with sideload and capacitor. And again, I'm no capacitor expert, but I believe what sideload did was it would take data in a secondary file and use that data to trigger an alert or to evaluate logic to trigger an alert. You absolutely can do that with Flux, although you can't pull from the local file system for security concerns, but you can provide data to a Flux task in alternate ways. Is there a way to suppress a task from firing? Absolutely. In fact, in the UI, it's a simple switch of the toggle to disable a task and silence that alert. It's a great question. Again, from Joel, on join, will you get a new timestamp, or will the timestamp of origin querying in InfluxDB be preserved? So when you join data, it uses whatever data is in the rows that get joined. So if you have a timestamp in a row, that timestamp will not be modified when you join that data, unless in some way there is an experimental join function that lets you modify modify the data as you join it. But no, you won't get a new timestamp. It will preserve the timestamp of the data before the join happened. It'll be the same as after when the join happens. Another comment from Joel is a Neo4j connector would be nice to have also. 100% agree. That would be really cool. Yeah, Flux is always open to contributions. So if you want to look into a lot of the other data sources, you absolutely could contribute a Neo4j connector to Influx or to the Flux language. That would be awesome.
Yeah, we actually have a couple of community members that are pumping data into Neo4j, so maybe we can get you connected, Joel. You guys can do that together. So I think the example you showed of joining, data from like a relational database to InfluxDB seems pretty straightforward to me. Joining temporal data can be a little tricky. Do you have any advice on that?
Yes, I do. And in fact, where it gets tricky is because InfluxDB collects data potentially nanosecond precision. If you're joining on time and there's any difference between those timestamps, it won't join the two rows because they're different. There's actually a truncate time column function in Influx that allows you to truncate the precision of your timestamps. So if there's timestamps that are milliseconds apart, you can truncate all your timestamps to seconds. So then those timestamps align, and in the join operation, those records will be joined together. That's the most common struggle that people have with joining temporal data, and it's not a foolproof method by any means, and there is the potential of records that may be dropped in the join because of that drop in precision. But to get fields to align on, or to get records to align on time, you can truncate the time columns, and that exists natively in Flux without any external or without importing external packages or non-standard packages.
But I guess you have to really understand what your data looks like before you do that.
You do, yeah, and that's a fairly common and accurate criticism of Flux, and I think a lot of this comes from just a lack of mileage with Flux because it's such a new language. We don't necessarily have a good idea of what that data looks like coming out of InfluxDB or any other data source. But I know with me personally, it's been a matter of mileage, and I know there's effort from the Flux team, active development going on to minimize that barrier of entry. I don't want to spoil too much because this stuff is all down the road, but there's a project in the Flux repo called TableFlux that changes the way data gets returned, changes the way that the data is formatted and grouped in query results. So that's all far future, but it is things that the Flux team is thinking about and working on.
When you were talking about processing data at a local instance, it just reminded me that if you do that, then you can make your local instance of InfluxDB kind of unique to that set of sensors or data, whatever it is, right? I've heard of instances where that can actually help with GDPR, because you could actually set a retention policy that might fit so that you don't break any GDPR requirements. Are there any other examples that you can think of that might be useful so that you would want to consider using InfluxDB at the edge?
A lot of it is again that data retention. I think it's maintaining high precision data, but still saving costs. So InfluxDB is cheap to run. You're essentially paying for the hardware that's underneath it. I mean, if you have multiple terabyte hard drive under this InfluxDB instance, you can store millions, hundreds of millions, billions of rows of data on those hard drives at the edge, but you don't necessarily want to transport all of that data into the cloud. So storing it all there, maintaining it all there, having some fairly long retention policies so that data sticks around for a while because you have the space for it and you don't have to pay the added cloud compute and transfer costs that come with storing and putting data in the cloud. You can do that all locally. You're really only limited by your hardware. So I think if you have the need to persist high precision data for a long time, especially, I mean, sensor data, depending on the nature of the data that you're collecting, sensor data is a good example of that. You need to maintain that, but still, as you're reporting back to a centralized cluster, you don't want to take up all that network bandwidth. You don't want to take up all the cloud storage disk space that high precision data would require, but you still want to maintain that data on the OSS instance. And if you want to query that data, you actually could, as long as your OSS instance is open to the public network, you could query that high precision data from your cloud instance and only call that or demand that network throughput, that high precision data at query time. You absolutely can.
Ryan talked about this briefly, and I know we've talked about this at previous events, building dashboards with a month. So you talked about it a little bit, but maybe you could just let everybody know, how do we do that now with Flux? We don't want like the last 30 days, we want, how was I doing in November?
Yeah, so Flux has introduced a lot of great functionality that our community has been after for a long time, and one of those is not just displaying by month, but aggregating by calendar month. That was merged back into or introduced back into Flux, I want to say 5 or 6 months ago, and it's still fairly unknown. A lot of people still ask about it, but that functionality exists and works. But yeah, you can aggregate by calendar month and calendar year. And the reason those are so challenging to handle is because they're variable lengths of time. The length of a year is not constant, and the length of a month is not constant. But you can absolutely aggregate and downsample based on calendar months and calendar years. It's as simple as passing a duration into your downsampling tasks. And so the duration unit for a calendar month is MO. So 1 month is 1 MO, and the calendar or the unit for a calendar year is Y. So 1 Y is a calendar year. So it's really easy to do. It's a matter of passing the correct duration value into your InfluxDB task.
So we can now make dashboards for management because they only understand months and years, right?
Absolutely, absolutely. In fact, something else you can do is Flux has an align time function. So this function was specifically designed for that month over month comparison, where, for example, you want to take or even quarter over quarter, depending on how you're aggregating the data, which quarters are also a duration value available in Flux. But you can create either a collection of data points or single data points, and then compare them month over month, all aligned to a single time. So you aren't just looking at, and I don't know if anybody can see me, but January, February, March, April, but January, February, March, April are all aligned, and you can compare the specific days in each of the months side by side. So that's a function that exists inside of Flux. It's called align time. It allows for month over month, year over year, quarter over quarter comparisons in a single dashboard or a single dashboard cell.
So I just want to ask again, so if I want to pull data, if I want to use the pull model, then I use tasks to be able to then scrape the data from my various endpoints. If I have that set up with Capacitor, is there an easy way to then kind of move that over to Flux? Is there some docs that you can point me to, or is there an easy way to do that?
So right now, tick scripts, the transition from tick script to Flux is a manual transition that is on my backlog of things to document. So docs don't exist yet, but they will, of converting tick scripts to Flux tasks. In the meantime, we know that there are huge deployments of Capacitor out there that with just hundreds, if not thousands, of tick scripts that are used to monitor infrastructures and fleets, and migrating those it's a non-trivial task. So what has been introduced with the V1 compatibility APIs in 2.0 is you can now set up a Capacitor instance and configure it to connect to InfluxDB OSS, excuse me, or InfluxDB Cloud, and use all the same tick scripts. The only caveat is as Ryan mentioned in his Q&A, is that you can't stream data from InfluxDB 2.0. It's only batch. So that'll require some updating of some tick scripts. But yeah, that's something on my backlog. So eventually there will be documentation for taking tick scripts and converting them to Flux. And yep. to add to that, I've been surprised by how much of a one-to-one translation there is between tick script and Flux. It's not the case in all cases, but I would say that tick script was somewhat of a starting point for Flux, where a lot of the methodology and data flow that you see in tick script, you can see that influence in the Flux language and how Flux is handled. So there's a lot of parity between the two. It's not perfect parity, but it exists.
Well, tick scripts scare me to death. I mean, they're easy to get started, and then I don't know what I'm doing anymore. I
don't think you're alone in that, Chris. And I think Flux, part of the goal of Flux was to set out to correct that issue in tick script. And in my personal experience, I feel that it has.
Two more questions, and they're kind of related. So the first is, you mentioned the anomaly detection package from Anais. What other packages should we look for that you think would be really useful?
That is a great question. Some of my favorite functions are actually in the experimental package, and this is you hear the word experimental and it probably raises hair on a lot of people's necks, but this is essentially Flux engineers who see an opportunity for something and they want to prototype it, but they don't necessarily want to include it in the standard library yet, or they see functionality that is missing from the standard library and they want to get feedback on it. Where those functions land are in the experimental package, or now, which this was recently introduced, is the contrib package, which allows community members to provide user contributed functions and packages to the Flux language. And that's actually where Anais's anomaly detection function comes from. And you have me curious, so I want to look up on GitHub because I have an idea of all the functions or all the packages that exist out there, but now you're going to get me to look. But I know some other ones. There's the Discord package, which is a notification package. There's, let's see, what else is there? There's the strings package, which if you need to do any string manipulation or regexing against strings, the strings package is definitely what you want. But when it comes to user contributed packages, we have a recent one that was contributed by Rohan Sharima, the naive Bayes classifier, which introduces some algorithms into Flux. We also have things like MQTT, the geo package, which introduces functions for working with geospatial data, which if you're looking to use the map visualization and the tile servers that will be available in InfluxDB Cloud and OSS, you'll want to familiarize yourself with the geo functions or the geo packages, because they provide really handy and valuable functions for not only manipulating, but filtering and working with geospatial data. They implement the Go S2 S2 sphere geometry library to accurately map points on a sphere. So the geodata that you're mapping is it's pretty cool. It's a fun package to play with.
So how do you avoid cardinality issues?
With geospatial data?
Yeah.
Very carefully. I mean, and this is a struggle with any data that's coming into InfluxDB. Part of it is how you're storing your data, what gets stored as a field, what gets stored as a tag. In the case of geospatial data, what it expects is actually latitude and longitude being stored in separate fields. So as those points come in, they aren't going to introduce cardinality because fields don't get indexed and they don't grow cardinality. What would introduce that is if you're bringing in additional tags for like location or things like that, but or sensor ID, whatever. But the lat and long values are expected to be stored in fields, and then the geo package provides functions that actually pivot those lat and long fields into individual columns, and then it operates and visualizes the data as lat and long are stored into individual columns. But on disk in the storage engine, lat and long should be fields. So cardinality, if data is structured in that way, cardinality isn't an issue unless it's introduced in some other way by adding a bunch of variable tags.
That makes sense. So last question, I promise. I could ask them all day long. So what's the best way to learn Flux?
That's a great question. And I guess I can reflect on my experience with Flux. And I came in, again, my background's in design. I'm a self-taught coder. Flux was, once I understood how data was flowing through Flux, everything else just kind of clicked with me. And you mentioned the presentation that I gave earlier this year and comparing Flux to water treatment and the water treatment workflow, pulling data from this vast pool of data and then filtering it and treating it, manipulating it down till it's something that's digestible and something that you want. Once I understood that that's how Flux works, everything else just kind of came into place. And really it's this plug and play, this testing, this tinkering. You begin to understand what each of the individual functions do and how they shape the data. So I think, and this might just be the way that I learn, but tinkering is how I did it. We provide, there's some Flux documentation that admittedly needs to be updated and will be in the very near future. In fact, that's beginning tomorrow. Once InfluxDays is over, that is my highest priority is refactoring some of the Flux documentation to better introduce the language, better introduce the data workflow, and those foundational concepts that users need to understand as they're coming into the language. So improving that documentation is again a high priority for me, but I think just getting in and using it, maybe taking a SQL query and trying to, or an InfluxQL query and trying to replicate that query in Flux to see the different results, or hopefully the not different results that you get. That's a good way to do it.
I guess one advantage everybody has over you, Scott, is that they can use the UI, use the script editor, kind of point and click, look at the queries and start to learn that way as well.
Absolutely, absolutely. And I think I'm an outlier. I like to switch over to the script builder, but I know as you build out those queries, and that's a great point, Chris. So the query builder, what it lets you do is you select a bucket, a field, a tag set, and you'll get data returned from the database. And if you want to see what that query looks like in actual raw Flux, you just switch to the script builder and it'll persist that query except in code form. So that is a really great way to familiarize yourself with just really basic Flux queries.
Awesome session. And we took up all the time plus the extra 5 minutes. And like I said, I could ask even more questions, but thank you so much, Scott. We really appreciate your presentation. And we'll get this recording up so everyone can take another listen because there was a lot of details in here.
Great. Thanks for having me. It's been a pleasure.